This is Uncommonly Remarkable. We have surprisingly casual discussions about the lives and notable accomplishments of community leaders, entrepreneurs, and everyday folks like you and me. Think of this podcast as an opportunity to learn something new and to pick up on an entrepreneurial tip or two through open conversation. I'm Artis Beatty. I'm a doctor of optometry and the chief medical officer for My Eye Doctor OD. Though we will inevitably touch on topics within my area of expertise, the opinions and conversations held here are separate from my work with My Eye Doctor. Welcome to the show. Today's guest is Daniel Tausan. He's founder of Timeline Scientists and one of the most passionate minds I've met when it comes to making complex biology simple and actionable. From understanding how cells shape our health to why daily ketosis might be more important than you think, Daniel breaks down the science of longevity, DNA protection, and metabolic resilience in ways you can actually use. Whether you're an athlete, entrepreneur, or just someone who wants to live better for longer, this episode is for you. Let's dive right in. Ladies, gentlemen, all you remarkable people, please welcome Daniel to the show. It is so exciting to have you on the show with us today, Daniel. It's been one of those things I've been looking forward to over the course of the last several weeks from the first time that we connected and talked. And so I can't tell you how much I appreciate you taking part of your day out to spend with us today.
Likewise, I am thrilled to be on Uncommonly Remarkable.
Well, I tell you what, we've talked about a lot of topics on the on the show, and we've woven this theme that's been really around people who have some sort of insight or something different to offer the population at large. And most of the time, there's some sort of underlying entrepreneurial spirit that they're manifesting, and that's bringing to light some of these things. And the topics of fitness and health and wellness are topics that I touch on quite a bit just because of my background. And so as we talk through things today, I'm going to pepper you with questions because not only am I really interested in some of the things that you know and that you've brought to other people, but I think the audience in general is going to be very curious about things.
I'm ready. I absolutely love sharing the nitty gritty. My favorite topic is cell biology. So everything I have today to offer, longevity, fitness, performance, it's because I liked cell biology. And the consequence was, getting the wealth of longevity knowledge, which now people are, coming to the forefront, realizing I better start taking care of myself before I get put in the direction of the medical system or the worst case scenarios.
Well, I think you're exactly right. And when you say cell biology, I think people go, what in the world is that? So talk a little bit about the things that are included in the global topic, the big topic of cell biology.
Yeah, so I'm sure everyone's heard stem cells, right? I don't think you can be on planet Earth today without hearing that buzzword. So the stem cell is how you get grants, right? So if you want money, you say stem cell. The reality is it's just cell biology. We've been studying what we are, for millennia. And within the last 200 years, we can really drill down to the point where we say, we are actually made up of about 200 different cells. So we have one genome, exact same genome in every single cell, but about 200 different cells, brain, muscle, bone, lung, connective tissue, immune cell, all that stuff. So we realized, we're cellular beings, right? That all work it's an unbelievable orchestra working together in order for you to be able to speak, think, share, feel, and do all this, the beauty of having emotions in a human experience that possibly we signed up for, and so the cell biology is really called the basis in which you can make good decisions and understand what's going on. It's the machinery behind life. And to me, it's been absolutely bonkers to learn that at one point in time, every single one of us was one cell. And then you did the thing where you went from one cell to trillions. Now, I can't verbalize how I did it. You can't verbalize how you did it. And we can spend lifetimes studying it, but we all did it. That's kind of the joke of it all, is it's happening constantly. And this is a pursuit that for me, it's worthwhile. And luckily, it's complicated enough that there's work for numerous lifetimes. And from it, we gain the insights related to how to live better lives, right? How to live smarter, because our intellect does play a big role with, where you're going to end up. And knowing things is one part, acting on it is the other.
So, I think maybe we take a little bit of a step back even farther because, if it's been a little while since you've been in biology class, you probably remember that we have cells, and to your point, the 200 types, right? And they perform very specific functions. However, when we were one cell, we had to help determine which of those 200 cell types the rest of the cells were going to turn out to be. And that's where stem cells kind of come into play, because as functioning human adults, we have these cell types that are differentiated, but stem cells are cells that have not decided exactly what they're going to do over the course of their cell life. Is that right?
That's absolutely correct. And so in the adult, you have plenty of stem cells. They're not the same as the one, embryonic stem cell. So very different in that regard, because the embryonic stem cells, what people think when you hear the word stem cells we're talking about, but it's not. The majority of the time, adult stem cell, for example, you got in your intestines, adult stem cell all over your muscles. So if you injure your muscle, phenomenal tissue that regenerates. It's also a tissue that never gets cancer. That's a very interesting thing that no one really talks about too much. Very fascinating. Your heart has no reserve pool. If you damage your heart, you're screwed. Your brain, very limited. So if you damage the cortex, you're not going to get new neurons. But if the hippocampus or other areas that has constant neurogenesis, you get regrowth of portions of your brain. And that's always tentative, right? But it's a little harder so I will do a little hand waving there. Lungs, terrible. They don't regenerate very well. Blood, phenomenal. Every 120 days, your blood reconstitutes itself. So liver, really good. So we have portions in the body where we're constantly undergoing a turnover and change. And so that requires a reserve pool of cells that can constantly spew out more. And this is a part of the longevity game, because the better you can take care of those niches, they're called, these little microenvironments where the stem cell lives, the adult stem cell, the longer you have in terms of lifespan. So if you're burning through your honey jar of stem cells, you're going to see not only call it a reduced life expectancy, but you're also going to see easier times getting problems, the diseases and whatnot. And so this is all just cell biology. That's why I said, the stem cell is how you can get grants, because it never really changed from 100 years ago when we didn't know how to name it to now how we give it very specific names. And it's a little bit deceiving because we say stem cell as if it's one cell doing the thing, but it doesn't ever work on its own. That stem cell can't function unless it has all the support around it. So even if you isolate it, it needs all the support. So understand that, again, we're playing this game of, I need to make really good models to study it. But the reality is you have to approach it more with a holistic sense. You're not trying to take care of one cell. You're trying to take care of systems. You're trying to take care of patterns of processes. And the better your processes, in other words, metabolism, the better it is that your quality of life is.
So what started you on the road of really wanting to understand more about cells themselves, and what sparked the urge to build a knowledge base?
I'm a space cadet. So we're talking 6 years old, I'm asking questions of, what Nietzsche and the existentialists asked back in the day, like, Mom, why are we alive? Right? I'm 6 years old. Hey, if I zoom in, what do I see? And someone says protein. What does a protein look like? It was ridiculous. So my parents would always just kind of make jokes. That's their way of responding, because they obviously can't answer some of these questions. And I saw it that biology or this sort of natural sciences, maybe if I was born 100 years ago, this would be naturalists, right? Mm-hmm. That to me was describing our existence. This is like the universal laws. Call it whatever you will. You want to call it source, you want to call it God, you want to call it reality, you want to call it nature. I'm fascinated. I want more. I want to see more. And I know with my eyes, as you can tell, my glasses, I don't see well, but I'm the visions I can make are very easy. So the abstracts are like the abstract visualizations of the world, very easy to me. So as science describes experiments, someone tells you, okay, this is the conclusions. It's natural for me to be able to put this abstract visualization of DNA or protein or whatever. And I didn't realize that that's not everyone's skill.
Yeah.
And so I'm very much so, if you're not talking to me, I'm daydreaming. And I'm usually daydreaming of trying to connect things together. Like, it's a little bit of a problem where any organ, if it's working too much, you need to bring some calm to it. And I've had to learn, it's been a challenge to calm my mind down. And I've been actively understanding, okay, well, if this is true for the liver, if this is true for the kidneys, if this is true for the heart, it has to be true for the brain too. So I need to act now before, things go down the bad path for me. And so it's been almost a indulgence.
Yeah.
It's like, your dopamine hits. It's like the playing on the Instagrams or whatever people are doing on the social media. It's not really my thing, but to me, the knowledge of going to get more, listening to more information is just that. And it's more of I don't really buy into what I would say is the general history of the planet, because I can see from biology what the truth is. The fact that, well, all of us have 99.9% same DNA. And then every once in a while you meet a small group and they're like, oh, a little bit of Neanderthal. Oh, a little bit of, Tausan. Oh, there's some differences. That's the reality. That's what's real.
Yeah.
Whether we can connect the appropriate story, that's fun. I'll listen to anybody's story, but we have some hard evidence in which we can go out and say, hey, I have a protein and so does a tree. It's about 40% the same. Does that mean that we're, from the same sort of, call it, realm of existence, or whatever, however you want to approach it? But to me, that's been the pursuit, is a little bit of this time capsule that is planet Earth and what's really happened here. If I can have a superpower, it would be just to press pause, fast forward, rewind, and watch what happened here.
See what happened.
Yeah.
Yeah. So, when we start to think about the genome, I think it's really interesting that when you talk about DNA and what share or the size of the genome, because humans, have a fairly large genome, but that's not as big. In fact, plants in general have a much larger genome, right? And so it's kind of interesting to think about, we evolved, we are intelligent, we're talking to each other, we're having a physical conversation, but plants, which we look at and say, well, they don't do much, have a way more complex genome than we do.
I love that you brought that up. Absolutely. So human being, about 25,000 genes. A rice plant, 4 times as much. So
it's just crazy, right?
Bonkers to think, at one point in time, the idea was the more genome, the more complexity. And we sort of didn't really think that was going to come out. We sequenced the worm. We then looked at the fly. Oh, wait a minute, less chromosomes. What's going on? Okay, keep going, mouse. Okay, there's more. Come to a human. Yeah, okay, more. Oh, rice plant, 4 times as much. What's going on? Okay, sweep that other idea under the rug and let's keep going. And so this is where I say we put in stories and then there's science. And it's sometimes hard for people to separate which one's which. And so you can see how there's fashions in science, and this is information from like 1980s, 1990s, when I was still, like hobbling around, figuring out how to walk and talk. And so, we come into the equation, into the conversation at different time points, not realizing that opinions have changed. So
that's a good point. Yeah.
Yeah. Well, opinions have changed. Now, what's the sort of consensus that's trying to push the leading edge? And is it in the same, call it, vein as what was before? We're completely wrong based off of, just assumptions. It's a very much so a fashion in science. And it's very hard for people to see it, even for people within the field. People laugh. There's textbooks that will laugh at a scientist, Lamarck, who talks, the contrary to Darwin. People are familiar with it. Darwin was natural selection. And then, Lamarck was on the premise of what you do in your life does have an impact to your offspring.
Mm.
So, in the 80s, 90s, that was all laughed at. Textbooks, heck, even to this day, if you open up a textbook, you'll see how they sort of slander Lamarck with, tall necks and giraffes and examples. They're not necessarily important. But the funny part is today, what do we call Lamarck's very much so hypothesis, very much so ideas? We call it epigenetics. Right? It's absolutely phenomenal. The most important topic of today's day and age is actually understanding how are we using the genome.
Yeah.
I can exercise one leg and I can keep the other leg completely isolated, very, very sedentary. And what do we see? We see that one leg's epigenome changes and the other leg epigenome change. Within one person, we can see how that shifts, just based off activity. So, this is the thing where there's fashions in science. And this is what I also love. This is the fun part of getting into it. This is why it's important to always have the conversation. See, when the science conversation is being had in the media, you know right away that has absolutely nothing scientific. When you hear two scientists talk, it's very much so, oh, what was the data? Oh, you got this? What's your controls? Are you confident? You are? Have you done this experiment? I have done this experiment. Okay, can you do that? Come back. We'll talk. Great. It is super productive.
Yeah. And I think that's very true, in that, from a practical perspective, people who are trying to consume information, are looking for, what was the answer, and assuming that the answer is valid, versus people who are studying, researching, who are scientists. They are looking more so at how did you get the answer so that you can prove that the answer is valid, right? And so that's a difference in the way people who are scientific really observe things and think about things versus people who just want to know, is this true or not, right? And so I think there's a lot of need for people to understand how difficult it is to actually prove some things are the way that they are. And why that's really important for people to do in order to mitigate assumptions about other pieces that maybe we haven't proven yet.
Yeah, there's a very well-known trope in science is that there is a burden for the observer. So any science starts first with an observation. So the guy who makes the observation, he's you can imagine he's pouring sweat, and he has to come in and report back. They sent me out on this expedition, and it got funded, and they had limited funding, and I had to take in everything I could in terms of into account, and this is what I took into account. But I didn't factor this thing in. I didn't add the other thing, and there was birds overhead, and were those interacting or interfering? I don't know. And so he comes back and he gives his statements, his knowledge base, he builds it up, and no one has any bit of call it suspect that there's anything issues with it. Like, okay, that's what he said. On we go. This is it. And so there's a massive burden for the observer. And the same idea when you do the next step in science. So you observe something. If you did a good enough job, okay, we can move forward. You have to measure and do the tedious parts no one wants to do. Have controls and make sure everything is in proper comparisons, right? If you compare someone with Alzheimer's to someone with diabetes and someone with, COPD, it doesn't work. The biology is going all different ways, haywire. That's not appropriate. You're not going to get any meaningful information. And so there's a burden of, did I compare things properly? And then I set up these measurements within, call it fair standings. If I had to make a microscope slide, did I make it 3 microns? Did I make it 5 microns? Did I mess up a little bit? And it's a 4 micron slide, and that's why I counted more. You know what I mean?
Yeah.
There's so many small details that once you make the graph, no one asks the question. But the person who actually had to do the work, you really hope that they are phenomenal, immaculate with their techniques. And usually that's the case. You usually have individuals that have been doing this for years. They're very comfortable. They know how to do their, set skill set.
That's right.
But when you don't, it is often the reason why we're in that crisis, call it today, of replication. Why it's 40 to 60% of the stuff that's out there is kind of rubbish. You can't really move on it or use it. So we're in a very interesting time. And I think it's never been more important for the average individual, for the everyday man, to sharpen up their language. It's because if you don't understand the very specific language that's used, you don't have to know the technical jargon, but you have to know the ways to approach it. Hey, what did you observe? you need to ask that question. Hey, what'd you measure? What'd you use as a control? And then, you can build onto that in terms of knowing how to get at what is the real science. Because, if you're presented with a piece of information, I can ask, can you extract the science from this? And then just put away all the opinion and story to the side. And if the quality's there, it doesn't matter if the story's wrong. We can always build on the science. So, for example, 100 years ago, we drew blood lactate levels. And so now we know in men and women of whatever demographic we sampled from, if we did a good enough job of characterizing them, I can say 100 years ago, this was the lactic acid level in the blood of, a runner. And I can compare it today. Did it change at all? And it doesn't matter that they thought that lactic acid was causing muscle soreness. And now we think, okay, we're a little bit different. We have ways to be able to tease that apart. That doesn't matter. That was the story. Yeah. And it's important to have stories in science so that we can bring the information to life, because we're not computers. If there's no emotional connection to the information, we'll forget it.
I've never actually thought about it like that, but that's a really interesting and really good way to think about it, right? Because if your technique is sound, then you are able to later figure out whether or not the results that you had correlate to something else. But if you have a faulty technique, it just makes it hard to do. And it's not necessarily important that the story that is behind what you did is accurate as much as it is that the information is accurate, that's a really, really cool thing to think about. And I think all of this matters because when people are out and they're thinking, gosh, I have this lifespan and I have a health span, and I really want my lifespan and health span to be about the same, so that I have great quality of life the entire time, right? I think people are really thinking, what are the things that matter most in order to have this long health span? And are there things that I should be thinking about, in your case, on a cellular level, that really help improve the quality of my life today, tomorrow, and into the future? So as you kind of think about that in terms of cell biology, how do you start to put this into something that a layman can use practically as they start thinking about life and quality of life?
Yeah, that's a very good point. I love how you serve that up with the cellular aspect and then this sort of other aspect. What are we doing with that? And so for the everyday man, it's not really important what's happening at the cellular level. To tell them, hey, you have to protect your DNA, and your DNA is the most important. If you damage DNA, that's the renewal of the cell. That means it can't make more. It's not the brain of the cell, it's the renewal, it's the gonads of the cell. And so who cares for them? It's just information. There's no connection to it. Whereas this is the part where it's next to impossible as a coach, or call it as a individual, that I'm trying to get you to take on behaviors that you want to take on. But we have this blockade of your past resistances that are going to prevent you from taking action. Now, the more I've done this, the more I realized, okay, this person really wants to know. If they know, they'll take action. If they don't know, they won't. So that's my personality. The more I know, the more I'm like, okay, this action is going to result into making sure my DNA is protected. Therefore, I'll adopt this, action more so into my lifestyle. And I know what I have to avoid, like the plague. I have to stay away from if I don't want disease or problems, coming down the line. So most people don't care about this. Let's see, we're talking maybe like yourself, and then, a few handful of individuals that care about, the molecular aspects.
Right.
But the unfortunate thing is that there's a barrier of entry to understand a lot of health if you don't care to learn even the simplest parts of, call it, the cell or our physiology. So this is the reality of it. Like if I'm telling you, hey, fasting is a non-negotiable, you have to find a healthy relationship with food. If you don't want to understand why metabolically that's important, you're never going to understand how to set your metabolism. So for everybody, there's a way in which to be able to connect with them emotionally on what's going on with their health. And when everything is great, that's often the hardest time to connect with the person. It's a weird trope, because I do have a few individuals that they're phenomenal, but they're high performance individuals. and they just want to keep pushing the envelope. And so, get a scientist in their team. They have someone to talk to, call it at their discretion. And so they bring me on. So that's not the everyday man. The everyday man learns on their skin, right? They get hurt, something bad happens. Okay, now I've lived it. I have scars. Now I have to act and change it from it. I'll learn from this disease. I'll learn from it. So that's the everyday man. And what people that are listening to this, that nothing's bad happened yet, learn from the rest of us. So I am, as much of a brainiac as I am, I'm also very much so the everyday man. I had a lot of health problems. I was born with health problems. That's what really pushed me to solve them. And, medical system wasn't able to help, right? Not with a lot of it. So then it came the aspect of, well, I'm in charge of it. If I'm in this field, if I'm interested in why can't I solve my problems? And it was just slowly one after another, where I would be allergic to every animal, horse, a cat, a dog. I can rub a cat in my face now, no issues, and it is very difficult when you ask for help from different medical professionals, because you get a lot of different opinions. You're going to say, oh, well, yeah, it's your allergy, you're stuck with it. Another one say, well, yeah, it's an allergy, here, you can drug it. And every once in a while, you'll meet a guy and be like, okay, well, the truth is you have to do a very drastic change to your lifestyle. You're doing things wrong, but if you're willing to do it, here's what you can try. It might not work, but you have to figure out your own biology. You can come back and ask for a little bit, but I'm not actually supposed to tell you this. Go read this book, right? Because they have there's a certain liability in that sense. So for the everyday man, today is pretty exciting because we are in a little bit of a personal opinion here, but the most unhealthy civilization that's ever graced this earth. Right? There's never been more chemicals. There's never been more exposure to different modalities, Wi-Fi, electricity, radiation. Our great-grandparents, 0.000, we're talking minuscules. Us, trillion-fold higher. How's that going to impact our health? And then not even to mention what's in the food, what's in our detergents, and who actually has it the worst from experience here are construction workers. People that are working in construction are subject to some of the most ridiculous, call it, diversity of chemicals that get absorbed through the skin. And usually they come in like hydrofluoro compounds. And so they're constantly being bombarded just to name a few. There's probably more that I haven't yet interacted with. So we are in a stage where I would say people are getting very aware to the state of our health, and that shouldn't be in such a, call it, we're a technologically advanced civilization, but biologically we're destroying ourselves.
Well, and does that go back to, you made a couple points, I think, earlier that maybe these are connected. One of them was developing a healthy relationship with food, and we'll talk about that just a little bit. But the other one that struck me was protecting DNA. And it feels like, as we're thinking about all the things we're exposed to, that we may be in a position where our DNA is being bombarded by a bunch of different things that maybe other peoples before us did not have, and that's having an effect on our overall health and lifespan. So can you talk about that piece just a little bit more? Because I think that construction piece is important. I mean, I think about our clothing. I think about all of the technology we use, the things that we eat, how things are preserved. It's great because it's allowed us to do a bunch of things in society, but it may have a consequence.
Yeah. So I'll say first, there's a very easy reference. It's called the hallmarks of aging.
Okay.
And it's very difficult to read and interact with it unless, you spent a lot of time learning, biology. But it's a very simple takeaway. The most important, and I may take a step back because it's not scientific, right?
Okay.
To say most important. So I understand I'm trying to drop down the language, but the most important is the DNA. If you damage DNA, then the cell cannot heal itself. The next step is all the protein and the machinery. So the things that are doing the work. You can think that's our labor force on the construction yard. If the labor force gets damaged, then everything's going to slow down. And if everything slows down, you can imagine all right, well, we need to be able to put steel beams in, but before there's steel beams, we need, some type of foundation. And foundation hasn't set yet, but the steel beams are coming. It's going to be a cascade of problems. So you have a lot of give on call it the workers. You can bring in more. You can take some out. You can, give them rest. But if you keep pushing it over time, what you see is that they'll shift. And once they shift, your metabolism entirely shifts. So we go 1, 2, 3. DNA most important. Proteins, proteostasis, what's maintaining the function in the cell is going to be more stable, very stable, but you can shift it. And the part that's the least effective, or call it the least important, is, for example, the metabolites or the signals that are coming in and out of the cell. So, for example, you have, I'll use one very specific one that people get at the blood test, is a creatinine level. So be like, doctor's like, I would like to know your creatinine levels, your kidneys, and your muscle. But I've seen that one go up 17-fold in military personnel. And when that military personnel went to a civilian doctor, because he was training outside of, the civilian doctor was absolutely mortified. Now, I'm convinced that, had he gone to a military personnel, they have that information, they have the databases. It's not what's taught to, the everyday man, what we have access to. And so just an example how those signals can be drastic, but there's no health issue long-term. So you can see, if you measure this and it's super out of range, it's not as alarming, let's say. Obviously, if the everyday man has that marker out, that could be problems. I'm not saying that, right? Okay, thank you. So this is sort of the rules within, call it the cellular compartment. And this is how we can test. This is how, if you go get a very fancy blood test that has a lot of measurements, I can take a look at it and I can say, okay, I'm not worried about these 4. I am a little bit concerned about this one, and this one over here, hey, it tells us that your liver's struggling and we need to do something. You have no problems now. You're not seeing any symptoms, but this is our early warning sign to take action now before things get worse. And we have that ability now, right? If I can do it, others can do it. The only difference is that people aren't trained to do this, right? Like you don't go and just get schooling for this. You have to care to look through papers that didn't publish the specifics, but they have the data. So you can go and take the data and then you can present it to the individual. And this is what I've been doing. This is my, call it, novel entrepreneurial mindset, where I find it interesting. So I know other people find it interesting, and I will be that bridge to the interesting piece of information. So that's what they get access to when they get access to me. I find things interesting, and it helps them to realize, like, why is that cool? Why is that important? Why is that valid? And for a lot of what I've combed through is I've actually combed through exercise physiology, because when you look at disease, that's the easiest thing to study. What's hard to study is health. You come to me and you're like, hey, I'm healthy, but I want to get healthier, right? I want the health span. I want the lifespan. Like, well, what do I do? If I measure, can I say anything? And so I've defaulted to saying, all right, well, we know athletes do a good job on only the cellular basis. We can maybe wrap back to do a phenomenal job of reformatting the cell and adapting the cell to last a long time, to do great things. And so I can say, well, if you're trending towards what an athlete looks like, you've adapted your systems. And this is the part where it also becomes very complicated, because biology works in thresholds. And I'll just throw that in with maybe a little too much complexity. But for example, your heart at one point in time, heartbeat will slow down when you become more fit, and each pump is more efficient. Your heart becomes a more efficient pump. So your heart rate starts coming down. Now that's an adaptation. You have to take that into account when we start examining, call it, more and more of these physiological biometrics, or call it, biometrics, biomarkers, just measurements of the body we can take, whether it's delayed or live. And so this is the impossibility, because what's nice is all of the foundational work has been done more or less for biology, meaning we've made the big connections. And in those big connections that we made, we had to exclude the outliers. But the outliers are a real person. So now we have to go back and say, all right, well, you're an outlier. What's going on? What other things can we take into account? What is the way that you need to approach adopting the non-negotiables, adopting the proper lifestyle habits, And, how can we get you back on track? Or what can we learn from you?
Yeah, you said a couple of things here too that I think we should probably just kind of think about differently, or at least bring them to the forefront, right? So is it not then easy to get into a little bit of a trap if you use others for proxy? As an example, if you're using athletes as a proxy, then how do you make sure that as you're doing a comparison for a person who is not an athlete, or let's say professional athlete, that we're looking for things that could be similar to the professional and those things are good, versus how do you think about using age as a proxy? So that's where I think bioage comes into play, right? If you're thinking about people who are in an age bracket and you're comparing the individual to others in that age bracket, you could put a person into a little bit of a trap because they, compared to their age bracket, they may be phenomenal, but then compared to that athlete, they may be very underwhelming, right? So how do you think about that?
It's brilliant. Absolutely brilliant. This is the difficulty. This is the impossible challenge. This is a genuinely impossible challenge because a cross-sectional comparison, right? Comparing me to you, for example, that's okay, right? We have to do that because the only way I know what's going on in here is by looking at what's going on in other people.
Right.
What's very useful is if we have the cross-sectional comparison at the same time as we have the longitudinal of the individual. So I have data day 1, day 2, day 3, day 4, day 5, day 100. Well, we're obviously not going to follow everyone around with a laboratory kit. And so, the more we get interested in ourselves, maybe you go get a panel of 100 biomarkers from your blood today, and then again in a year, and then 2 years from now, 3 years from now, 4 years from now. And that, I say, is the most important, right? It's more important than anything because, I can say, okay, the reference range for prostate PSA, the prostate specific antigen is underneath, I might butcher it, but like 4.5 for a 60-year-old and 3.5 for 50-year-old and so on and so forth. I might be off by a 10 or so. But if yours is very low this year and the next year goes up by, let's just say 1, that's a big jump, but it's still underneath the reference range. And doctor's like, well, it's underneath the reference range, you're fine. No, you're not fine. Oh,
that's absolutely
because
right.
Your delta is everything here.
Yeah.
And so this is I'm thank you for asking this question. So I've built out biological age calculators in which I have to preface it's very difficult to do because I have to now try and find 60-70% of the population this applies for. And if there's anything special going on, if you have any kind of condition, and if you're an athlete, and you can't use it. Sorry, it's for that.
Yeah.
And that's because there's a lot of, how to say it. It's like this whack-a-mole game in biology where if you push one thing down, you don't know how everything else is going to adjust for it. And there's something called a bystander effect and a compensatory effect. So as things break down or, let's say come up, breakdown is very easy to explain. You might have, for the moment, something else compensate to maintain that, neural link or metabolic stability. You have a compensation. And so you might measure something and be like, well, look at this. This is the thing that's important, but it's only compensating for the moment. And you didn't catch the actual break. And the same thing where you can have, protein 142 go up and you'd be like, all right, that one's really important, but it's just a bystander, meaning it went up just because everything else is going up.
Yeah. Yeah.
And you might fixate on that. And so the other way to go around it is you need a handful of very, call it valuable biomarkers and measures. So when you have a handful, then you have more confidence to say, okay, you don't have a clotting issue. Yeah, D-dimer went up, which is a clotting marker, but it goes up if you go up the stairs fast. You run up the stairs, D-dimer goes up. Okay, so that's not a great one to use to decide whether you have issues with clotting or not. Let's take, factor 4, factor 5, factor 10,
Right.
factor 8, so on and so forth. You wouldn't actually do those markers, but you know what I mean? You want to catch more of the picture. And so this is the same idea for cholesterol. It's the same thing for lipids. It's the same thing for your bioenergetics with what's going on in your blood. You could just measure blood glucose levels, but man, that's a lot of data for nothing. That's fine.
Yeah.
Yeah, that's fine. You probably already know without measuring your blood glucose levels of hey, there's an issue. Okay, so let's start addressing the issue, because once the issue is dealt with, your ability to control your, call it, blood glucose may very well. So this is some of the non-negotiables for health. And you're thinking, well, I want this. What do I have to do? Well, number one, let's just throw it out there. You need metabolic flexibility. Another way to say that, it's metabolic resilience. When something comes in, it's not going to cause your system to go haywire. You can adjust for it. You can incorporate it and still have the ability to, the next day, switch back to another resource.
Yeah.
So I can use fats, I can use ketones, I can use sugars. Your body needs to be very competent to be able to take those resources, shift them around, and then produce your own. If you never allow your body to actually kickstart the machinery to produce their own, well, I can tell pretty quickly.
Yeah. So I love that, right? Because that bridges the gap between we learned so far we got to protect our DNA. And that comes in a number of ways. And we have all these environmental factors that some of which we can control. So in the controllable factors, we should be thinking about those things that are going to provide us at least some level of DNA protection. Then we start to shift into biomarkers and thinking here about metabolic markers. And you just said something that I think is one of the things that's a hot button for a lot of people, is understanding the relationship with how they eat and why they need to make certain choices. Because if you're looking at general information, right, depending on when you look and where you look, it's either have all the carbs or have none. It's either be in keto or not. It's enjoy whole foods versus it's not really that important. Like, there's a lot of conflicting information. And so when it comes down to being able to think about low fat diets, high fat diets, like how do you guide people to start thinking about that so they can make decisions for themselves?
So beautiful. First off, the word diet, when someone tells you diet, is a good way to say nothing, right? I'm on a keto diet. I have no idea what you're eating, right? And the reason why that is because you can't define things by what they're not. You don't say, hey, that's not a hippopotamus over there. I still don't know what it is. Hey, that's not a tree.
That's great. That's
right.
Great.
So when
that's
you're
right.
defining something by what it's not, you've done nothing. Right? You've excluded a slight portion of it, and that's great. Hey, I'm not eating carbohydrates, or I'm eating carbohydrates. Carbohydrates are massive in terms of what are you eating? Potatoes, jicama, rice, sorghum. I have no idea, right? And so the diet is a way to be able to camouflage the quality of food that you're eating. So when people interact with me, we drop all this, but we need to understand what keto is trying to get to. And this is a big, big one. So when people are approaching it, what I would say is every single day, you must enter ketosis.
Okay.
This is very simple. I don't care what you do. You want to eat carbohydrates, that's completely fine. You want to eat bad quality carbohydrates, that's also up to you. It's your choice. If you like the sugary muffins and all the other, call it, bakery stuff, I'm a glutton for it. And that's my cheat meals, or cheats,
I mean, it is delicious, right?
And so you can do all that, but you must enter ketosis every single day. And why is that the case? Because if you neglect that metabolic machinery, there's a consequence. You're going to get stagnation in the very direct meaning of it. You're going to push a certain metabolism into the liver and into other tissues. So ketones are, it's not just for energy. This is where, unfortunately, we have the buzz where you have a lot of people talking that sound like they're very in the know, but they're good showmen. Because in the know it's not very interesting to listen to, because it's very technical and trying to parse out, needle in a haystack. And the short version is that ketones, more importantly, are a signaling molecule. So this is why you must enter ketosis. The molecule acts as a signaling molecule. What does it signal? It signals resilience. It signals and tells your brain, protect the membrane. That's the, you don't have to, there's the biology. It's that simple. The molecule tells neuron, turn on, protect the membrane. So it's like, okay, that's my signal to be more resilient. This is why when someone is in a fasted state or when they're really watching their sugars, they have clarity for a long time. Oh, I finally wrote my book because I adopted this type of practice. Thanks. It's been great. Hey, this anxiety issue I've been having at work because, I always smash a muffin and, put sugar and milk in my coffee, and I'm a lawyer and I'm doing all these things. I'm not having all those anxieties. I've stopped having the heart palpitations. I no longer sweat and smell like, a wet rag. It's been great. And not only that, but like the work is way higher quality. And it's not because their brain's using ketones for energy. It's because there's a signaling molecule. There's also the control of hormones. There's this massive cascade, this waterfall that comes with you simply understanding the principle. Okay, I must enter ketosis every single day. Now you miss a day, no problem. You miss 2 days. Hey, come on, get back on it. You start missing multiple days at a time. There's only 365 days in a year. So if 280, 300 aren't in the right ballpark, it's not a matter of if, it's not a matter of who, it's just a matter of when you'll start seeing more and more problems. And the medical system can't wait to start naming it differently, to try and give a fancy, new disease, new way of approaching it, and to be able to camouflage the basics, or call it the root of where a lot of our problems are coming from. And it's honestly overconsumption.
So you keep giving really very clear, good advice on things, right? And so thinking about being in ketosis at least some time of every day is a solid thing that people can kind of wrap their brains around and understand that that's important, not from the thinking about, I'm in a keto diet, but more because it has a function that helps us regulate the body systems in a way that's going to be better for us over time, right? And so maybe then let's talk a little bit about what it is that you've hinted a little bit around what you bring to the table when people reach out and contact or work with you. So can you talk a little bit more about your coaching and what your approach is, and who it's a good fit for?
Yeah, absolutely. We talked a lot about the data. You don't need data to come to the table and be, hey, I want to get to a better, healthier state. You can take the very easy one, which is your resting heart rate. If you're comfortable enough, you can get a peak heart rate. So there's things that we can do to give us an idea of health and measures outside of, go drawing blood. And so I've really seen two demographics, and it's more shifted towards combating disease. And I have a few individuals that, hey, I like you on my team, and they use me as a scientific advisor and a coach. I keep them accountable, and I bring things to them on a regular basis, in which allows what I would say is a formative assessment. I check in on them, and some of them have been longstanding clients, and so it's evolved over the years. So from the beginning portions for those gentlemen, it's, well, let's get you on a knowledge base, because you have to make a decision day in, day out of what you're doing. Mm-hmm. Hey, you're going to go out with a bunch of clients. Okay, fine. You're going to do this to yourself. What can you do to offset it? What's going to be the next day? What's going to be the following day after? And so that's the initial portions where it's, bringing in life philosophies that are not necessarily full of all this biology, but then just carry the weight of the biology, right? Just so that I must enter ketosis. It means I must, do these actions. And so, it's now shifted to more of me checking in on their, call it, philosophies that reflect their mental emotional state. Because this is something that I've shifted in terms of my way of approaching health over the last 4 years, is I've seen that no matter how much information I give, it's more so trying to understand where the person is right now with their mental challenges, mm-hmm. and how their previous self has set up the emotional responses to take on life's challenges. And it's a bit of that resistance busting, as a friend likes to call it, of the emotional states. And it is helpful when you have someone to talk about where they're, hey, am I starting to become ignorant in aspects? And it's a general, very vague thing, but I'm trying to kind of wrap around some conversations where I'm checking in with them to make sure that their mind is not being fixed on particular things. And it's allowing them to check in and rank themselves. Hey, you set this out for yourself for the last month. How did it go? It could be very business specific for them. How did it go? Why didn't it go the way you wanted? Why did you take that response with those individuals? Did you ask these questions? You didn't. Why didn't you ask those questions? Isn't that, the human thing to do? Okay. Right. And so that's kind of giving them the opportunity to, it's not health anymore, but it's still very much so.
Sure.
They're a way to be able to check in with what I would say is something that is the most valuable for everyone, is that they would like to be very cognitive, lucid at 80, at 85, whatever. They don't want to be in the corner, unable to have a conversation or participate. So how do you maintain a sharp mind? That's still a question that I can't tell you exactly, but I can guide you towards the metabolic ones, the philosophical ones, and the spiritual ones that align you with what you came to do, right? So that you're not pretending to be fake. That's one type, I guess, of my favorites, call it, because it's pushing my boundaries too of what I can present and how I can interact and bring value to these individuals. The combating disease, it's been very challenging, and it's often just trying to find what belief has set into the individual that's led him down a pathway for disease. And diseases come in very similar, call it, patterns of inflammation, and then it roots into Crohn's or arthritis, something like that. And then there's other ones that are a lot more challenging, in which it's a very specific, narrow issue that's going on. And so what I can do is, I'm not your doctor, but what I can do is I can help you prepare to interact with doctors, so you become a better patient, so you know how to ask the right questions, so you know who to go to, and that you know how to come best equipped with information to speak with them. Because if you just say, hey, I'm not feeling well, good luck. Like, you're not going to get help. But if you can tell them very specifically of the services that you're looking for, or present to them, hey, I am very narrow in this problem. I think it's a muscular and nerve problem. I saw a neurologist. I know it's not the membrane of the ear, yada, yada, yada. So it gives them confidence to navigate and learn about their body. And that part is, something that I enjoy. I'm a professor without a university, so you can use me in the sense of bringing yourself forward and prepare yourself to know the landscape to a very, call it, clear detail. Hey, these are the cells, these are the processes, these are the tests that are available, and we can work from there. And I've really kept it as broad and open as I can, so that I can have, call it, the widest reach for myself. I do value every individual I work with because I've learned from them.
Yeah.
If I didn't get a chance to work with someone with lupus, I wouldn't know what the end result could be. I didn't know that you can manage it or kick it, or go through life in certain ways, and then to ask them what they did. And not everyone can follow the same line or same actions, same behaviors, but at least if they know if someone else did it, then they can try and walk in that similar path. And I've really enjoyed being the nexus of information. And this is where I say, sure, I have some credentials to my name, but it's the fact that when I'm presenting someone, I do have to do the work at hand, be diligent to say, I don't know something. Give me a second, I'll try and figure it out. Or, hey, it's best to go talk to someone else, right? And to really try and be accountable for the moment. Not, hey, I did good, 5 years ago, so please, just take my word for it now.
I love that. And I think, when we often along the path of the show, I've talked with people who have had to have interactions with the health professions in general. And one of the things that you see over and over is learning how to communicate about you to the person that's going to help you. And I think there is a real need for people to understand what it is that's happening in a way that they can communicate that to the person that is trying to help, and then also think about how they interpret the information they're given back. And so what you being in that position of being able to help people get better at what they bring to their doctor, I think is a phenomenal thing, because so often people are not well informed. They have a lot of things that they've kind of thought about, and they just don't know how to communicate it. And having a source or a resource to help them narrow those communications can be invaluable when it comes to diagnosis or treatment, or even just understanding what's going on. So that's amazing.
Yeah, I appreciate that. It's I think an important time to be able to bridge a lot of the information that's stuck at universities to the public, to the everyday man. And technology, biotechnology is only getting more complicated. DNA tests, all that kind of stuff. Can you trust your DNA test?
Yeah.
Is it really telling you, the end all be all to your health? And, from someone on the backside of being in the space where, hey, I have this data, I have this information, how do I sell it? It's really helpful to be able to, bring confidence to individuals so that, hey, you have a 30% increased chance for arthritis. Well, just so you know, our pool of people we sampled was everyone had arthritis. So,
yeah.
Right. Keep in mind, we're gonna label what we had in terms of from our resources, and I don't see that people being also on the forefront to understand really the complexity or the simplicity behind these things, and very few people ask the questions. I've noticed this, with this the clientele I work with for keeping them in top shape. They ask a lot of questions. They're like yourself. They want to know more. They want to know more. They want to know more. And I recognize often when people are struggling and they're not in the best shape, they often have a lot of convictions. They don't ask the questions. And then those are probably the best people to sell DNA tests to.
Yeah, that's really interesting to think about, right? Like you accept that things are the way things are, and that there's some inevitability to it, rather than questioning whether or not it has to be the way it is, and if there's some way to change that path by doing things that you can control.
Yeah, and that's the big, I think, I guess I'll just say it out loud, is that genetics are not people's problem, right? Like it's your problem. If you are in your 20s, 30s, 40s, and you're saying you're getting the spiel of, it's your genetics, it's definitely not the genetics.
Yeah.
If the genetics are the problem, very early on. So 95 to 98% of us, we come with all the superpowers of a human being. Everything, all the insulins, the growth factors, the scavenger receptors, the immune defenses, we come with all of it. And somewhere along the line, we take very bad ideas, very bad beliefs, and we ignore the symptoms, the emotions, the body communicating to the forefront. Hey, your patterns of behavior are not leading to a timeline in which you're thriving. And this is where, I would say the people that are the centurions, this is where I get a lot of my longevity information, is the centurions, I would say, are phenomenal at having this connection with their emotions, this biofeedback. They're often trying to, bust balls and make jokes and poke fun. They're very spirited, and they have a reverence for life. They have this pizzazz. Like life can take me at any point. That's fine. Whenever my time comes, my time comes. There's no worry, for things that are outside of their control. And good luck trying to shake their faith in whatever it is that they've set their eyesights on.
Yeah.
And that's something, again, is very difficult to, I think, tap into, but very much so present in front of us, for those that are willing to take the moment to just be observant.
So as we've talked about a lot of the basics, right? So we talked about protecting our genetics, protecting our DNA. We've now talked about maybe genetics are not the end all be all. We've talked about our relationship with food. We've talked about understanding health span and lifespan, and really thinking about our cognition versus our physical aptitude as time goes on. If people wanted to learn more or to find you to talk, what would they do? Where would they go? How would they find you?
The best is through the website, timelinesciences.com. Right? We use science to describe the timeline that we're on. We all have one timeline we're sharing. We have our individual timelines. So timelinescience.com. I'm getting a lot of help for the website. Initially, I put it together. Now it'll get a little revamped. So there'll be a lot more things to come. You'll be able to see the programs that are on there. Right now, it's just contact me in order to get information, what I can offer. We'll have to like that initially to get the most, options, but they're refined. So whether it's a group coaching calls that are alignment, that are on a weekly basis, or whether it's a one-on-one, or whether it's a package to, hey, I want to tackle this thing. I want you here for a month in these times. This is the best way to get in contact with me, just directly. CavaletsCience.com. There's only me on the back end, so you'll talk with me directly. I do use Twitter, X, but I'm not much of a social media guy. I'm very much a scientist at heart.
Yeah.
So one thing at a time, right? I got the science down here. We got the business we're working on. Social media, I'll probably have to recruit someone to take that on from me.
Fair enough. Well, I'll make sure to link the website in the description so that people can find you, read more about you. And it feels like we scratched the surface on a lot of things. And there may be opportunity for us to really dig deep into some of these things over time, right? Because I think there are pieces that we could pull apart and really help people kind of wrap their minds around it, maybe make some decisions on how they want to move forward and the way they think about themselves. And so if that's the case, I'd love to have you back and we can expound on a few things as time goes on.
Well, it'd be a pleasure. Yeah, the specifics I think are great, whether it's, heart health, liver health, eyes, all of it can take an entire hour for sure to even scratch the surface.
Yeah, the eye stuff is phenomenal, and we could spend some really good time on that. We talked a little bit before about all the questions that I typically get when I'm talking to patients about eyes, and so we may have to carve out some time to do that. But I can't thank you enough again for spending some time with us, and I really do hope that we get to spend more time together because this has been fascinating for me.
Absolute pleasure. It's been your insights have been brilliant.
If you've made it this far, then I have to thank you for your time. I hope you've learned something new and enjoyed listening to the discussion as much as I enjoyed having it. I'd love to hear from you about the show because we're working really hard to bring you great content and the feedback really helps us get better. If you like what you've heard or watched, for those of you who are streaming out on YouTube, then take a split second to give us a thumbs up or a like. It really helps other people like you find the show too. And no one likes to miss out on the good stuff, so go ahead and subscribe and hit the notification bell so you don't have to wonder when or if there's a new episode. And until next time, stay remarkable.